Indefinite integrals. Indefinite integrals are one of the important part of calculus. Before we get into these, let us know about some of the sources or some of the basic points. In that, first one is derivative. Derivative provides us the information about the rate of change of the quantity involved that leads to the solution. Or differential calculus allows us to solve the problems that are concerned with finding the rate of change of one quantity with respect to the another quantity. For example, f of x is equal to cos x plus x power 5 minus 12. Find f dash of x. Given the position of an object, position function of an object, determine its velocity function. Given the demand function, calculate the elasticity of demand. Antiderivative. Antiderivative provides us to solve the problems that are a reverse of the derivative problems. For example, f dash of x is equal to cos x plus 3x power 5 minus 12. Find the f of x. Given the velocity of a function of an object, determine its position. How much do consumers benefit by the purchasing some of manufactured goods at a price determined by the supply and demand? These are some of the examples of antiderivative. So, antiderivative is the reverse process of differentiation. The antiderivatives are also known as indefinite integrals or simply integration. It helps us to solve the problems also where the rate of change of the one of the quantity is given with respect to another quantity, and we are concerned with finding the relationship between these two quantities. Now, antiderivative definition. A function capital F or capital F of x is said to be antiderivative of the function f of x, small f of x, if it satisfies capital F dash of x is equal to small f of x. Small f of x means our given function for all x in the domain of f. The notation is used to represent all antiderivatives of the function or indefinite integral is this is the symbol to represent all antiderivatives of the functions or integrals of the functions. So this is wavy line, okay, wavy line. Wavy line. This is the symbol to represent all antiderivatives or integrals of the function. That is, by using the notation integral f of x dx is equal to capital F of x plus c. Here small f of x is called integrand C. Here capital C is there, referred as constant of integration. Constant of integration. So completely the right hand side of the expression, capital F of x plus C, is called integration, or indefinite integral of f with respect to the independent variable x. With respect to independent variable x. Now enter into the important point. Why we are adding C on the answer, or on the result of the antiderivative of the given function every time? Y plus C here. Note that the function capital F of x is not unique, and that an infinite number of antiderivatives could exist for a given function. F of x అంటే మీనింగ్ ఏంటంటమ్మా, ఎఫ్ ఆఫ్ ఎక్స్ అనే ఫంక్షన్కి క్యాపిటల్ ఎఫ్ ఆఫ్ ఎక్స్ అనే ఫంక్షన్ ఏమని తీసుకున్నాం మనం? ఇది యాంటీ డెరివేటివ్, లేకపోతే మనం ఏమనుకున్నామంటే ఇంటిగ్రేషన్ కదా. సో ఒక ఫంక్షన్కి యాంటీ డెరివేటివ్స్ కానీ ఇంటిగ్రేషన్స్ కానీ ఎన్ని ఎగ్జిస్ట్ అవుతాయంటే ఇన్ఫైనైట్ నంబర్ ఆఫ్ యాంటీ డెరివేటివ్స్ ఆర్ ఇంటిగ్రేషన్స్ కుడ్ బి ఎగ్జిస్ట్. ఓకే, ఫర్ ఎగ్జాంపుల్ capital F of x is equal to x cube, capital G of x is equal to x cube plus 5, and h of x is equal to x cube minus 2. Observe these all antiderivatives f of x, g of x, h of x. The derivative, now we are going to find a derivative. F dash of x is equal to, yes, it's clearly 3x square g dash of x is equal to 3x square plus 5 means here constant integration is always 0. H dash of x is equal to again 3x square minus 2 means minus 0. Constant function derivative is always 0. So it is clear that these functions differ only by some constant value, and that the derivative of constant value is always 0. So you can add any constant to antiderivative we get another one. Okay. So for this reason, we need to add a constant c to answer of the or result of the integration. Okay. So I repeat once again, antiderivative is the inverse process of or inverse operation to the derivative. Is not completely determined. In other words, f of x and g of x are antiderivatives of the function f of x on some interval. Then f of x is equal to g of x and f of x is equal to g of x with some constant c also. For some constant here c. Geometrically this means the graph of f of x and g of x are identical except for their vertical position. So we conclude that for each answer of integration we must add the constant c.